we go over the homework problems in section 6.4. In this case here, we're going to answer the following regarding the letters in the word Georgia. And there are 3 parts. In A, you want to determine the ratio of vowels to consonants. Okay, in this case here, if you look at the number of vowels in the word Georgia, you're going to see that there's 1, 2, 3, 4 vowels to the consonants. There's 1, 2, 3. Okay. The vowels are A, E, I, O, U. The rest of the letters are consonants. So here that ratio of vowels to consonants will be 4 to 3. Okay. And then part B, the ratio of consonants to vowels. Well, consonants, there are 3 consonants to 4 vowels. So it'll be 3 to 4. And this is the colon that we use to represent the word to. And then the ratio of consonants to the letters in the word. The number of consonants in that word Georgia is 3. There are 7 letters in that word. So it'll be 3 to 7. Okay. Problem number 2. We're going to find the missing number in the proportion. We got 8 over 4 is equal to 4 over x. Okay, in this case here, we can do cross multiplication here. We can do 8 times x, that's going to give us 8x, equals to 4 times 4, that's going to give us 16. Okay, so 8x is equal to 16, so to find out what x is, we divide both sides of this equation by 8 to get x is equal to 2. So x equals 2, or the missing number in that proportion is 2. Okay, problem number 3 is an application type problem that deals with proportions. There are approximately 4 pounds of muscle for every 7 pounds of body weight of a certain animal. For a 168-pound animal, how much of the weight is muscle? Now we can set this up as a proportion. 4 pounds of muscle for every 7 pounds of body weight. So here, we're going to say 4 over 7 as a ratio of muscle weight to the body weight. Okay? The other ratio must be the same. Muscle weight to the body weight. So here, we're trying to find out how much weight is muscle. That's your X. And then the 168-pound animal, that's the body weight of that animal. So that 168 has to be on the bottom because of the consistency of our ratio on the left side and the right side. Muscle weight to body weight. The other side, muscle weight to body weight. We don't know what the muscle weight is. We know what the body weight is. That's 168. That goes on the bottom. So you have 4 sevenths is equal to x over 168. Now let's do cross multiplication here. 7 times x is 7x equals 4 times 168. And that's 672. And then you're going to divide both sides by 7 to get x by itself, or to solve for x. So x must be equal to 96. So for this 168-pound animal, that body weight, well, that muscle weight, I'm sorry, is 96 pounds. Okay. Problem number 4 is determining which one is the better buy. You have 3 apples for 63 cents or 6 apples for $1.38. Okay, one way of doing this is finding out what the unit price is for each one of these. For 3 apples at 63 cents, we're going to do 63 cents, take that and divide that by 3. And you're going to get 21 cents. And then you have 6 apples for $1.38. We're going to divide $1.38 by 6, which will be 23 cents. If you compare the unit price, you'll see that this one is smaller than the other one. 3 apples at 63 cents gives a smaller unit price than 6 apples for $1.38. So 3 apples at 63 cents would be a better buy. Okay, problem number 5. On a map, 1/4 inches represents 4 miles. If two cities are 19 inches apart on the map, what is the actual distance between them? Okay, we can set this up as a ratio if we like. 1/4 of a mile of an inch represents 4 miles. They're 19 inches apart, so inches to miles means inches to miles here for this ratio. So we want the actual distance, which is going to be the x going on the bottom. Now, if we do cross multiplication, 1/4 times x is 1/4 x is equal to 19 times 4, that's 76. So 1/4 times x equals 76. Now the next step is to multiply by 4, which is the reciprocal of 1/4, and you'll end up getting 304. So the actual distance between the two cities is 304 miles. Okay. Problem number 6. It takes a word processor 26 minutes to word process and spell check 8 pages. Find how long it takes her to word process and spell check 36 pages. Okay, so now the ratio can be from time to pages. I'm going to say 26/8. The other ratio must be from time to pages. So we find out how long it's going to take. The minutes will have to be on top. That's your x. 36 pages, that's the number of pages that's on the bottom, because the ratio on the left side must be consistent with the ratio on the right side. Minutes to pages, minutes to pages. So we cross multiply. 8 times x, that's 8x, equals 26 times 36. By the way, I'm doing this on the calculator. That's 936. Divide both sides by 8 to find out what x is. And it will be 117. So it's going to take this person 117 minutes to word process and spell check 36 pages. Okay. Problem number 7. Alan, Betty, and Carol invested in a corporation in the ratio of 9 to 10 to 11, respectively. If they divide the profit of $45,000 proportionally to their investment, how much would each receive? Okay. Now, we're going to have to set this up as an equation. So here's how we're going to do this. I'm going to let x equal the unit profit. Okay. Or the unit profit of that investment. Okay. Now, Alan is going to receive in a proportion 9 times that unit profit. So for Alan, he's going to receive 9 times x. Betty is going to receive 10 times whatever that unit profit is, or 10x. Whereas Carol is going to receive 11 times the unit profit, or 11x. Now, if we add these together, that total profit is $45,000. So here, Alan's profit plus 10 Betty's profit, which is 10x, plus Carol's profit, which is 11x. That's equal to $45,000. Okay, that's the equation. 9x plus 10x plus 11x equals $45,000. Now let's add the like terms together. 9 plus 10, that's 19, plus 11 is 30, so that's going to be 30x is equal to 45,000. And then to get x by itself, you're going to divide by 30, so that means x is equal to 1,500. So we're looking at the unit profit of $1,500. And we want to find out how much will Alan, Betty, and Carol receive. Okay? Well, to answer that, Alan is receiving 9 times whatever our unit profit is, which is in this case $1,500. So 9 times 1,500 is $13,500. Betty is going to receive 10 times the 1,500, or $15,000. And then Carol will receive 11 times the $1,500, which is in this case $16,500. Okay, so that's the amount that Alan, Betty, and Carol will receive: $13,500, $15,000, and $16,500 respectively. If you add these together, you'll see that the total profit will be $45,000. Okay. Problem number 8. When two gears are mashed, the revolutions per minute, or RPM, are inversely proportional to the number of teeth, as shown below. In one machine, the RPM ratio of the larger gear to the smaller gear is 5 to 8. The smaller gear has 260 teeth. In the second machine, the larger gear revolves at 200 RPM and has 190 teeth. The smaller gear revolves at 500 revolutions per minute. And this is the ratio: RPM of the large gear to RPM of the small gear. That's the same as the number of teeth on the small gear to the number of teeth on the large gear. Okay, now let's find the number of teeth on the large gear of the first machine. Okay, now we say in one machine that the RPM of the large gear to the small gear is 5 to 8. So already that ratio is 5 over 8. The small gear has 260 teeth. Now notice this ratio. The number of teeth on the small gear is given as 260. That goes on top, and we're going to let x be the number of teeth on the large gear, the first machine. So this is your first ratio right here. 5 over 8 is equal to 260 over x. Now let's do some cross multiplication and solve for x. 5 times x, that's going to be 5x. That's going to equal to 260 times 8, which will be 2,080. So 5x is equal to 2,080. Divide both sides by 5, you'll get x is equal to 416. So the number of teeth on the large gear would be 416. Okay, so that's the first part. Now the second part of the answer is finding the number of teeth on the small gear, the second machine. Okay, let's look at what's given to us in the second machine. The large gear revolves at 200 RPM and has 190 teeth. The small gear revolves at 500 RPM. Okay. The large gear revolves at 200 RPM. That's the revolutions permitted for the large gear to the revolutions permitted on the small gear. That's 200 over the revolutions permitted on the small gear. That's 500. And we want the number of teeth on the small gear. That's x. the number of teeth on the large gear has 190 teeth. Okay, so you have 200 over 500 is equal to x over 190. Now, if you want to, we can reduce 200 over 500 as 2/5. And that's going to equal to x over 190. Now we can cross multiply. 5 times x is 5x, equals 2 times 90, that's 380. So you have 5x is equal to 380. Divide that by 5, you're going to get x is equal to, let's do 380 divided by 5, that's going to be 76. So the number of teeth on the small gear of that second machine is going to be 76. Okay, now this is one of those application type problems, so you have to pretty much set this up as a proportion and then solve that proportion. Okay. Finally, number 9 is this. Jeremy weighs 130 pounds on Earth and 299 pounds on another planet. Find Amy's weight on that planet if she weighs 110 pounds on Earth. Okay, now this we can set up as a proportion as well. The weight on Earth to the weight on another planet. We'll set this up as 130 over 299. That's the weight on Earth, which is 130, to the weight on another planet. That's 299. We want to find Amy's weight on that planet. She weighs 110 pounds on Earth, so her ratio will be the weight on Earth to the weight on the other planet. So that's 110 over x. Okay, because if I'm going to say the weight on Earth to the planet, then the other ratio has to be the same thing. Same thing, weight on Earth to the other planet. Cross multiply, you're going to get 130x is equal to 110 times 299. It's going to give you 32,890. Then divide by 130 on both sides to get x by itself. So that means x is going to be 32,890 divided by 130, which will give you 253. So Amy's weight on the other planet is going to be 253 pounds, while her weight is 110 pounds on Earth. Okay, so this should assist you with some of the problems in section 6.4.